All right, everybody, this is Gigi from Kauai Community College. Let's talk about the Stinky log. Okay, the Stinky log. If you follow my videos, you would know that there are two types of equations that we deal with. One is the onion, like this, right? So, X appear only once, and onion have layers, so you just undo the layers. In this case, to undo log, we would use exponent. 2 is your base, and 3 is your exponent. And this right here is the value that you would get when you take the base and raise to the exponent. So x minus 5 will equal to 2 to the third power, which is 8. So the next layer to undo is to add 5, and x is 13. And that is an onion problem, and that's not new. That's something we've learned before, right? And then, we always should check our answer. So when we plug in 13, we'll end up with log base 2 of 8 is 3, which is true because 2 to the third power equals 8, and we are good. And 13 is our solution. Now, with that being old material, the new type of equation that we would look at is the stinky log, right? So, what makes it stinky? Well, take a look here. We have log on the left hand side, we have log on the right hand side, and x is here, x is there. It is not an onion. Okay, so good thing though to notice that both of them has base 2, which is great because we can apply property of logs, right? Which is the previous lesson. So let's go ahead and get these logs on one side. That means add log base 2 to both sides of the equation to undo subtraction. And property of log says that log base a of x plus log base a of y, when we combine or when we condensed, will equal to log base a of, what are we going to do with the input there? X multiplied to y. And this property is equivalent to when you multiply things with exponents, you add the exponents, right? So log is the exponent. So when you're adding the two logs, you really are multiplying the values, which would be x and y. So in this case, we will apply that property and say log base 2, and we will multiply the input, which would be x minus 2 multiplied to x. So you will have log base 2 of x squared minus 2x is equal to 3. And guess what? That now looks like an onion. So to undo log, we will use exponent. 2 to the third power is 8. So x squared minus 2x will equal to 8. And oh boy, look at that. What is that? That is a quadratic. So we would make things equal to 0, ax squared plus bx plus c equal to 0, so that we can factor and solve for x. Now when we do check our answer, x equals negative 2 will not work, and x equals 4 is perfectly fine, so x equal to 4 is our solution. Okay, so that is the gist of stinky logs. Make sure you get logs to one side. all the things with x's to one side, apply property of logs, and then that will give you an onion to peel off the layers. All right, now let's take a look at one more Stinky Log here. Ooh, so first observe base 3. They all have the same base, which is good. Okay. Now on the left hand side, subtraction, we have this property again that said log base a of x minus log base a of y will equal to, right? Think exponent. When do you subtract the exponent? When you have division, right? So we will keep log base 3 the same, and what are we going to do with the input? Divide. So when we condense that into one log, we will have log base 3 of x plus 20 divided by x plus 2 equals log base 3 of 2. Now, you would say, well, do we want to get the other log to the same size so we can combine? No, actually. Let's observe this for a second. Both of them have the same operation, which is log base 3. So now we'll just look at the input. If they have the same operation, the input's got to be the same, right? In order for this to be an equation. So when we're matching our parts, we would say x plus 20 over 2 is the same as 2. That is now an equation with fraction. That's a rational equation. So how do we deal with them? Multiply by the least common denominator to clear the fraction. In this case, x plus 2 is the common denominator. So x plus 2 divided out x plus 2 on the left-hand side. We will have x plus 20 is equal to 2x plus 4 when we distribute. So for x, you will get x equals to 16. And don't forget, we got to go and check our answer. So when we plug in 16 to here, we will have log base 3 of 36. And when we put 16 to here, 16 plus 2 is 18. Again, property of log said I will go ahead and divide the input when I condense a subtraction of 2 logs. So 36 divided by 18 is 2. So that is correct. Therefore, x equals 16 is our solution. Okay, so that's great. So this is another way right here. Notice that. That's another way of solving. We are just matching the parts, okay? Now, we are not dividing by log because log is an operation. It's not a number. Here, we are just matching the parts and not dividing by log. And log don't cancel either. We are just matching our inputs when the operations are the same. All right. One more. Okay, observe and see. We can see that log base 3, that's great. But this is log base 3 of x, and this is log base 3 of x squared. I wish they were the same so that I could do a little u substitution. But wait, what do we know about property of logs when you have log raised to x, the input raised to the exponent? We can take the exponent and multiply. So the 2 goes up in the front there. Now, we can see that log base 3 of x, log base 3 of x, here being our variable. So we do a little change in variable, meaning doing a u substitution. Let u be log base 3 of x. And when you let u be log base 3 of x, your equation here becomes u squared minus 2u equals 3. And that is a quadratic. Make it equal to 0. Oopsie, that is not x. That is supposed to be u. And that is also u. And so u is 3 or u is -1. Well, we didn't start out with u, so we got to go and find x. Let's go back to our substitution there. Since u is log base 3 of x, and u could be either 3 or -1, then we would say log base 3 of x is 3, or log base 3 of x is -1, right? So when log base 3 of x is 3, then to undo log, we use exponents, right? 3 to the 3rd power is equal to x. So x is 27. Okay. The other case, when log base 3 of x is -1, again, 3 to the -1 power is equal to x. So x is 3 to the -1 power. Negative exponent is the reciprocal. So that is 1/3. When you do check them, and you should go and plug them in to make sure, I checked them, 27 and 1/3 both work. So those are both the solutions to my equation. Up next, you'll have Stinky exponential. So keep watching.